Ever wondered how a single message finds its way to just one device while another reaches thousands at once? Welcome to Lesson 5 of our networking journey, where we'll explore the four cast types that shape how data travels across networks: Unicast, broadcast, multicast, and anycast. Understanding these patterns is foundational because every packet you'll ever encounter falls into one of them. So here's the roadmap for the next few minutes. We'll start with Unicast, the everyday one-to-one delivery that powers most of your internet traffic. Then we'll look at broadcast, where a single message reaches every device on a local network. After that, multicast, a more selective approach that delivers only to devices that have chosen to listen. And finally, anycast, a clever pattern where the same address can route you to whichever server happens to be closest. Let's put all four side by side. Unicast is one-to-one, works anywhere, and powers things like a normal HTTP request. Broadcast is one-to-all, but stays inside your local network. That's how ARP and DHCP Discover find their way around. Multicast is one-to-a-group, configurable in scope, and shows up in video streaming or routing protocols like OSPF. And anycast is one-to-nearest, used across the internet for services like DNS root servers, 1.1.1.1, and CDNs. Let's zoom in on Unicast, since it's by far the most common pattern you'll encounter, roughly 99% of internet traffic. The idea is simple. The sender picks exactly one destination, and the packet travels through switches and routers until it reaches just that host. In IPv4, that's most of the address space from 1.0.0.0 up to about 223.255, and in IPv6, it's the global 2000-3 range, plus private and link local blocks. Every normal TCP or UDP conversation, a web request, an SSH session, a file download, rides on Unicast. Now flip that idea on its head. Instead of one specific destination, broadcast means one to everyone on the local network. The sender hands a single frame to the switch, and the switch floods it out every port. Host A, B, C, and D all receive a copy, whether they wanted it or not. You'll see this with ARP. When a device shouts, "Who has 168.1.1, and with DHCP Discovery, when a new machine is hunting for an address. Two important guardrails though. Broadcast only exists in IPv4. IPv6 dropped it entirely in favor of multicast, and it stays strictly local because routers refuse to forward it. Multicast strikes a smart middle ground. Instead of flooding everyone or targeting just one host, the sender transmits once to a group address, and only the devices that have actively subscribed receive a copy. Here, host A and host C get the most stream, while B and D are skipped. Devices opt in by joining a group through IGMP on IPv4 or MLD on IPv6, and switches use IGMP snooping to forward traffic only down ports where members actually live. You'll see this in action with IPTV, OSPF routing updates, financial market feeds, and MDNS service discovery. That brings us to our fourth and final cast type, anycast. Here, multiple servers scattered across the globe all advertise the exact same IP address. In our example, 1.1.1.1 lives in London, Tokyo, and São Paulo simultaneously. When you send a packet, the internet's routing system, driven by BGP, simply delivers it to whichever location is closest by path cost. It's the trick behind public DNS resolvers like 1.1.11 and 8.8.8.8, and behind virtually every modern CDN. Now that we've walked through all four cast types, let's pull them together into one reference you can use to identify any address at a glance. Unicast covers the bulk of the IPv4 space up to 223, while 127 is always loopback, and the familiar 10, 172.16, and 192.168 blocks mark private networks. Broadcast lives at 255.25255. But notice, it simply doesn't exist in IPv6, where multicast takes over every send-to-many job. And anycast, as we just saw, has no special range at all. It hides inside normal unicast space and reveals itself only through routing. With the theory settled, let's see where each cast type actually shows up in the networks you use every day. Unicast handles almost everything personal: your web browsing, SSH sessions, video calls, and email. Broadcast quietly powers local discovery, ARP finding a MAC address, DHCP handing out leases, or Wake on LAN booting a sleeping machine. Multicast drives efficient one-to-many delivery like OSPF routing updates, IPTV streams, and MDNS. And anycast is the magic behind public DNS resolvers, CDN edge nodes, and DDoS protection. One address, many servers, always the closest one answering. Anycast deserves a closer look because it's genuinely clever. Take Cloudflare's 1.1.1.1. That single address is announced from roughly 300 locations around the world. Ping it from London, you hit a London server. Ping it from Tokyo, you hit a Tokyo one. The routing system itself picks the closest, which gives you low latency for free, natural DDoS resilience as attacks spread thin, and effortless failover. If a site drops, BGP simply withdraws the route and traffic flows elsewhere. Stateless protocols like DNS love this because every query stands on its own. Now that you know the 4 cast types in theory, let's learn to spot them in the wild. Just by looking at an address, you can usually tell 10. or 127. is unicast, 224 through 239 is multicast, and anything ending in all ones for its network, like 192, 168.1.255 is broadcast. On Linux, IPA Matter Show reveals which multicast groups your machine has joined, and a tracer route to 1.1.1.1 from 2 different locations will quietly prove anycast is real. Let's lock in what matters before we move on. Unicast is your everyday workhorse, one sender to one receiver, and it's what nearly all your traffic looks like. Broadcast shouts to everyone on the local segment, leaves only an IPv4, and stops dead at the router. Multicast is the efficient choice when a group has opted in through IGMP or MLD, and anycast quietly routes you to the nearest copy of a service, which is why DNS and CDNs lean on it so heavily. And remember, on TV6 dropped broadcast entirely, handing that job to multicast. To make this stick, here's your cheat sheet. One page you can come back to anytime. Keep the 4 cast types in mind with their one-line definitions and pair them with the addresses that give them away. The all ones MAC for layer 2 broadcasts, 255.255.255.255 for IPv4's limited broadcast, the 224 through 239 range for IPv4 multicast, and FF008 for everything multicast in IPv6, and the line worth tattooing on your brain. IPv6 broadcast simply doesn't exist. Multicast took its job. That wraps up Lesson 5. Up next, we shift from the language of the network to the hardware that carries it. Hubs, switches, routers, firewalls, and load balancers. You'll see exactly how each one handles those unicast, multicast, and broadcast frames we just covered. Catch you in Lesson 6 on Dargslan.com or over on YouTube. Until then, keep practicing.